This call is now being recorded.
A very good day, dear students. Today, let us start with the second module, module number 2, corrosion science and metal finishing. In the beginning, let us go through the syllabus. In this, we have two subunits. The first subunit is corrosion. So this corrosion includes introduction to the corrosion, electrochemical theory of corrosion, factors affecting the rate of corrosion, ratio of anode to the cathodic areas, nature of metal, nature of corrosion product, nature of medium, that is in that pH medium, conductivity and temperature. Types of corrosion, we have two here. One is differential metal corrosion and differential aeration. Pitting and waterline are the two examples. Then we have corrosion control. Again, we have two methods here. Anodizing, in that example, anodizing of aluminium, cathodic protection, and sacrificial anode and impulse current cathodic methods. Then we have the last method, metal coatings. In this, we have only one example, galvanization. This is about the syllabus of the corrosion. Second subunit of the same module, number 2, is metal finishing. In the beginning, we have introduction to the metal finishing, technological importance, electroplating, introduction, principles governing the electroplating, that is polarization, decomposition potential, and over voltage. Electroplating of chromium, that is hard and decorative chromium. Electroless plating, introduction to this, electroless plating of nickel and copper, distinction between the electroplating and electroless plating processes. Then we have CO, that is course outcomes 2. So in this, after the module number 2, we'll have the causes and the effects of corrosion of metals and control of corrosion, modifications of surface properties of metals to develop resistance to corrosion, wear and tear impact, etc. by electroplating and electroless plating. This is what we are going to learn after thoroughly preparing for the module number 2, that is called course outcomes 2. So now let us directly commence with the subunit 1, that is the corrosion. So what do you mean by corrosion? In the first paragraph, we have the definition for the corrosion. So the term corrosion is used to denote a change. What is the meaning of that change? What here are going to change? A metal changes from its elementary state to the combined state when it comes in contact with the liquid medium. That means here, whenever the metal, a transition metal, comes in contact with the liquid medium or the A, in the presence of A, there will be changes in this physical property. That is, the metal in the elementary state going to form with the combined state. For example, iron metal gets combined with iron oxide. That is called the change here. The elementary state of iron gets changed to combined state of iron oxide. That is called a change, and that change is nothing but the corrosion. This is actually due to the chemical interaction between the metal and the environment. Why it happens so? Why this change occurs means there will be a reaction called electrochemical reactions. So that is, there will be a chemical interaction between the metal and the moist environment. So we can see the surface of the iron after corrosion. So this is what the image which represent the corrosion. The best example is the rusting of iron. This is what the rusting of iron we are seeing in this picture. This is also the iron pipe gets corroded. We can clearly see the corrosion pictures here. That is the product. Then let us go to the definition. How to define this term? The spontaneous deterioration and consequent loss of a metal or alloy due to the chemical or electrochemical attack by the environment. So this is the definition. I repeat this definition. The spontaneous deterioration and consequent loss of a metal or alloy due to the chemical or electrochemical attack by the environment. So spontaneous means itself, without the addition of any external force. The itself undergo deterioration, means destruction. Deterioration is destruction. So here the metal itself undergo the destruction. And also this is followed by the complete loss of a metal or sometimes alloys. Why it is? Due to the chemical or normally electrochemical reactions that is by the environment. This is what the definition. Now, let us directly go to the examples of corrosion. We'll have a well-known example, everybody knows. So, rusting of iron. When iron metal is exposed to the moist environment, the metal forms hydrated ferric oxide called rust, which is relatively non-protective in nature, and most of the corrosion cases are electrochemical in nature, taking place by an electrochemical attack on the metal in the presence of an air and moisture, and it is called wet corrosion. Most of the corrosion cases are wet corrosion in nature. This is what the example, rusting of iron. We can have this kind of examples. We can see in our daily life, in our home also, we can see the rusting of iron, the best example to study the corrosion. The mechanism of the wet corrosion is explained based on the electrochemical theory of corrosion. What this theory explains? What are the postulates of the theory? Let us go to this theory. This theory is mainly focuses on the corrosion cases, how the corrosion occurs, where actually the corrosion occurs, what are the reaction, anode reaction, cathode reaction, overall reaction, what happens, whether the hydrogen gas is liberated, if it is liberated, where and how. So to answer these questions, we'll have corrosion theory, that is called electrochemical theory of corrosion. According to this theory, let us go to the first point here. When a metal is in contact with moist air, or when dissimilar metals are contact with each other in a solution, large number of galvanic cells are formed with the existence of anodic and cathodic area on the metal. This is what happens in the beginning. If one metal is in contact with the moist environment or air, or sometime dissimilar metals, for example, iron and copper, iron and silver, etc. So iron and copper, the two dissimilar contact with each other in a solution medium. What happens here? A large number of galvanic cells are formed with the existence of distinct anodic area and the cathodic area on the same metal. That is, one part of the metal gets converted into anodic area, another part of the same metal behaves as the cathodic area. And in this corrosion, oxidation of the metal and the reduction of the species present in the solution takes place. So, what species undergo oxidation? What species undergo reduction? In this case, the answer is very simple. The metal, oxidation of the metal occurs. Whatever we are studying, the metal, maybe iron metal or a copper metal, that metal undergo oxidation. At the same time, the species present in the solution, maybe hydroxide ions or some other things, they may undergo reduction. So, oxidation of the metal and reduction of the species present in the solution takes place. Now, in the third point, what part of the metal undergo anodic? And which part of the metal acts as cathodic part? The answer is here in the third point. Anodic part of the metal undergo oxidation. That means the metallic parts, metal, whatever the metal we have, that metal part of the thing undergo anodic oxidation and suffers from the corrosion. Only anodic part of the metal suffers from the corrosion. Remember, not the cathodic part. Always the cathodic part of the part undergo reduction and protected from the corrosion. Always the cathodic part protected from the corrosion, whereas anodic part suffers from the corrosion due to the oxidation. Now, the electrons are transferred through the metal from anode to the cathodic. So, oxidation takes place at the anodic part. That means here there may be a release of a lot of electrons, and such electrons are transferred through the metal from anodic area to the cathodic area. So due to this corrosion, during the corrosion, the following reaction takes place. So due to the transferring of electrons from one part, that is anode, to the cathode, there will be a current. And during this corrosion, some of the reactions occurs. So let us go through the reactions. At anodes, as I already explained in the theory, oxidation occurs, that is M means metal, M stands for metal, undergo oxidation to give metal ion, that is Mn plus it releases some electrons, 2 electron, 3 electron, 10 electron, that is n number of electrons are released. Now, the cathode reaction, this cathode reaction, that is the reaction at the cathode, depending on the nature of the environment. If the medium or the environment is acidic, what happens? In the presence of dissolved oxygen, water is formed, that is 2 hydrogen ions combines with half O2 and 2 electrons gets added, that is released here and forms a water. In the absence of dissolved oxygen, hydrogen gas is released here. 2H plus 2 electron gives H2. That is, hydrogen gas is released if the medium is acidic in the absence of dissolved oxygen. Similarly, if the medium is alkaline or neutral, in the presence of dissolved oxygen, hydroxide ions are formed. How? Water molecules combines with half O2 and 2 electrons to give 2 OH minus ions. In the similar way, in the absence of a dissolved oxygen, water molecules combines with 2 electrons to give 2 OH minus ions, and again here hydrogen gas is released here. We can observe here clearly, in the absence of dissolved oxygen, in both the acidic and neutral condition, hydrogen gas is liberated. See here, this is the acidic medium in the absence of dissolved oxygen. This is the alkaline or neutral medium in the absence of dissolved oxygen. What is here? Hydrogen. What is here? Hydrogen. That means hydrogen gas is released at the cathode in the if the medium is acidic or alkaline or neutral in the absence of dissolved oxygen. These are the some useful reactions. Now, coming to the example, rusting of iron in the presence of a moist air. So, anodic reaction, iron undergo oxidation to give iron 2 plus 2 electrons. Cathodic reaction, one example I will take here, that is in the presence of a moist air here, water molecules combines with half O2 and 2 electrons to give 2 OH minus. The product of the anodic reaction, the cathodic reaction, let us take the combination of these two occurs here. Iron 2 plus is the product of anodic reaction. OH minus ion is the product of cathodic reaction. That is, iron 2 plus and OH minus ion combine to give FeOH twice, ferrous hydroxide. In the presence of oxygen, further ferrous hydroxide combines with half O2 and give Fe2O3 2S2O, that is hydrated ferric oxide, that is called rust. So this is the example for corrosion, that is rusting of iron, and these are the reaction. This is the final reaction. 2FeOH twice plus half O2 gives Fe2O3 2H2O, and this is called the rust. This is about electrochemical theory of corrosion. In the next class, we'll have types of corrosion. Thank you all.